first thing we're going to do is shout out to Rika, who's watching this video while we're stuck outside during the eclipse. Alright, so our second unit, this is first new material, it's matrices. And matrices are a simple yet beautiful way to organize data so that we can perform some operations that would otherwise be extremely complex in somewhat simple manners. So what is a matrix? A matrix is a rectangular array of variables or constants in horizontal rows and vertical columns enclosed in brackets. And you guys have studied rectangular arrays, probably starting in elementary, maybe in middle. So you're used to organizing data, and so this is one way to do it. So this is an example of a matrix, number 1 right here. So this is matrix A. All right? You will notice that matrices are named with capital letters. Now an element is a value in a matrix. It's either a number or a constant. A specific element can be denoted as this, A sub ij, where I represents the row and j represents the column. So let me give you an example here. Let's say we had matrix. I'm just going to make up a matrix real quick, throw in some nice little numbers. All right, so there is a matrix. This matrix has 2 rows. This is a row, this is a column, is a row, and it has 3 columns. Okay, so we have all these elements inside our matrix. Now, this element here, we would denote that element being in row 1 because it's the top row and it's the 3rd column, so it would be column 3. So element A, 1, 3. Row 1, column 3 is 5. Make sense?
What if you have like
Okay.
rows and like 10 digits?
Yeah.
That's a good question. We don't normally do operations with that at this level. You would use a spreadsheet at that point. Yeah. All right. So dimensions could also be considered order of a matrix. It's the number of rows by the number of columns. So a matrix is named by its dimensions, or this could be considered the order. So this one has 2 rows. So matrix A is a 2 by 3 columns, 2 by 3. So that would be the dimensions of the order of that matrix. Okay, so for each one of these, it asks you to find the dimensions of the matrix and then identify the specified element. Okay, so what are the dimensions of this one? How many rows does it have? 3, and it has 2 columns, so that is a 3 by 2. All right, B, what are the dimensions? 4 by 1. Okay, C?
2 by 4.
2 by 4. Okay, now we're to identify certain elements. Now, number 1 says row 2, column 3
There's no column.
does not exist.
Oh yeah.
I'm gonna say.
I was like, what?
Okay, now we could identify A3, 2, couldn't we?
Yeah.
Yeah, A3, 2 would be what?
8.
8. Okay, all right, B, 3, 1 is 3. C, 1, 4.
-1.
-1.
Go.
Okay? So basically, so far we've just done some vocabulary. What is a matrix? What are elements? What is the dimension or the order of a matrix? Okay, so let's look at different types of matrices. We have a column matrix. That's a matrix that only has 1 column. A row matrix. That's a matrix that only has 1 row. And then a square matrix. And we will be performing various operations on square matrices by hand. A square matrix has the same number of rows and the same number of columns. So take a minute. Give yourself an example of a column, a row, and a square matrix. Okay, so a column matrix would just have one column, and it really doesn't matter which elements you add to this matrix, but just give it one column. So we could call this 2, -3, 5. There we go. A row would just have a row. How about 1, 0, -1? And a square would have an equal number of rows and columns. I'm just going to do a 2 by 2. That's the one we'll see the most. We'll also work with 3 by 3s. Now, operations with matrices are quite simple, and we're going to talk about those operations in just a moment. Your quiz, or when I assess you, the simple operations like addition, subtraction, scalar multiplication, all the things we talk about today, you would definitely want to know how to do without a calculator. That would be on a no calculator section. And it actually makes more sense to do it without a calculator because it takes longer to type it into the calculator than it actually does to perform the operations we're doing today. Now, there are more complex operations, which matrices actually make things a lot simpler. And for those, we will be using the calculators, and I'll show you how when it's time. Okay, now equal matrices. Two matrices that have the same dimensions, and each, so like this is, what would we consider this one? A 2 by 1, and this is also a 2 by 1. So these are considered equal matrices because they must have the same dimensions. And what we'll note is that each element of one matrix is equal to the corresponding element of the other. So when we have equal matrices, this position 1, 1 is going to be equivalent to 1, 1. This position 2, 1 must be equivalent to this position 2, 1. Okay? So, because we know that 2x will equal y. And because we know that 2x equals y, in our second equation where we have 2x plus 3y equals 12, can we not sub in y for 2x? Because 2x equals y. So we could use substitution. Yeah, so we get y plus 3y equals 12. So 4y is 12 and y is 3. So what is x? X is 1.5 or 3 halves.
Wait, what?
Sure. Well, because we just solved to find that y equals 3.
Oh,
right here, 2x would equal 3 now, so x equals 3 halves or 1.5. Okay? So, because we had equal matrices, those corresponding elements would have to be equal, and we can use that algebraically to solve for those missing values. Okay, you try number 2. I didn't ask if you wanted.
Oh, you tell me. God.
Tell me sweet. Yeah, you tell me, Julian.
What? You say Spanish class?
You tell me, Julian.
You said Julian. My name is Julian.
Okay, so let's take a look at this where we should have started. Would have been by setting those corresponding elements equal. All right, and we could have approached this a couple different ways. we could move this x over and rewrite the first one as 2x plus y equals 3. Rewritten the second one as x minus 3y equals negative 2, and we could use elimination. We could have multiplied through, I don't know, the top by positive 3 to eliminate the y's. And when we do that, we get 6x plus 3y equals 9. So 7x equals 7, and x equals 1. So if x is 1, y is also 1.
Why would the 3y would wrote down?
I just moved this over here. Here?
Wait. But I thought you multiplied the y to get 3y minus 3y.
Okay, what I did here was I used elimination, and I multiplied this equation 3 by 3 to get this equation so that my y's would cancel.
Oh,
Okay?
okay.
You certainly could have also used substitution, and you would have gotten the same thing.
Yeah, it just took more work.
Okay? Alright, any questions?
Nope.
Alright, let's keep going then. Alright, so, oh yeah, they were all there for a sec.
2 by 3.
Okay, so when we take a look at matrices, these are really fairly intuitive and fairly simple. I know that last year my daughter, who was in Accelerated 1, went and took the ACT, and they had matrix operations on her ACT, and she knew what to do, even though she'd never seen them. So it just kind of, what do you think we do here? We add each element in the same position. So it is very intuitive. Now, when we get to matrix multiplication, it is not as intuitive. So
Multiply them across.
No,
add.
Just said that.
we will get
No,
there.
when you get to multiplication.
Scalar multiplication is intuitive, but a matrix times a matrix is not as intuitive.
Hey, that's what I got.
What's intuitive?
Yeah, I got that too.
Something you know how to do without being
Johnny,
taught.
you got that? I got that too.
Alright, so you try 2a, because all we're doing is adding matrix A and matrix B. First of all, can we?
Yes.
Yes. To add and subtract matrices, they do have to have the same dimensions or order, okay? So, if they do not have the same dimensions, you cannot add or subtract them. So that is key to adding and subtracting. So here we added a 2 by 3 with a 2 by 3, and the result was a 2 by 3, okay? So with matrix addition and subtraction, that will always happen. You can only add and subtract matrices that have the same dimensions.
Should we do B also?
I bet you could.
For C, do you just double each, like, multiplication?
Yeah. C is scalar multiplication. We'll talk about that in just a second.
Just multiply each element.
No, they switched them. That's confusing.
Alright. So here we go. When we add, we are just adding corresponding elements. That is all. Okay, so questions about A. Alright, so B is subtracting. So it might help you, it might aid you to rewrite them, especially when we switch orders. But with subtraction, it works just like addition. We are subtracting the corresponding element. So 1 minus 3 is negative 2. 4 minus 2 is 2. 3 minus 4 is negative 1. 2 minus a negative 1 makes, alright. 2 minus 4 is negative 2, and 4 minus 0 is 4 all day long. Okay, so addition, subtraction, no big deal. Your matrices must have the same dimensions in order to add or subtract them. The next thing we're going to talk about is scalar multiplication. So scalar is kind of like a scale change on a matrix. What this scale is going to do is it's going to multiply every element in B by 2. This one's going to multiply every element of A by 3. And then we find their sum. So I am going to go ahead and show you what 2B looks like. So if we take everything in B and double it, we get 2, 8, 6, negative 4, 4, 8. So this matrix represents 2 times matrix B. That's scalar multiplication. Alright, now 3A. So we would take each element in matrix A and triple it. So we would get 9, 6, 12, negative 3, 12, 0. And now, once we have done that scalar multiplication, you would add the elements that are in the corresponding positions. So we would get 11, 14, 18, negative 7, 16, and 8. Any questions about scalar multiplication?
No.
Alright, you try D then.
You try.
Already did. No, I just had
Is this our homework?
It is.
It is?
Oh wait, no, it's not.
Well, you already said yeah, you already said it was, so I think you can't take that back.
The board has
No,
said.
take it back.
Okay, so we have A and then 3 times B. And so the resulting matrix would be 0, negative 10, negative 5, positive 5, negative 2, negative 12. Okay, now, I do want you guys to pay really close attention. This capital X doesn't just represent the variable X, it represents the matrix X. It's a named matrix. And so we're solving for a matrix. What matrix can I subtract this 2 by 2 from? And the result be this 2 by 2. Okay, so to solve this,
Make up numbers.
you know we're not making up anything. So to solve this, we do very valid math here. If we want to solve an equation for X,
You said it equal to X.
we would move this to the other side by adding it. Now, when we add this, we are going to get 1, 2, 11, 11. And does that make sense? Is 1 minus 1 0?
Yes.
Yes. Is 2 minus 1 1?
Yes.
Is 11 minus 3 8?
Yes.
Is 11 minus 2 9?
Yes.
Yes. Okay, I have a question for you. Is matrix addition commutative?
Yes. I don't know.
See,
That
yes.
is.
Yeah, I don't know what community is.
No way.
So is
What's
matrix,
commutative?
if I were to do matrix X plus matrix Y, is that the same as matrix Y plus matrix X?
Yes.
Yes. Matrix addition is commutative. Now, keep that in mind as we start exploring other types of operations. Like regular subtraction is not commutative. 5 minus 2 is not the same as 2 minus 5, right? We can't switch the order with subtraction. So, The regular addition operation is commutative. 2 plus 5 is the same as 5 plus 2. Matrix X plus matrix Y is the same as matrix Y plus matrix X. So matrix addition is commutative. Now, today we looked at addition, subtraction, scalar multiplication, where every element was multiplied by the same number. So scalar multiplication, we talked about dimensions. What's another word for dimensions? I've said it like 12 times.
Order.
Order, good. And that's about it. Okay, so this is your homework. It's just 1 through 16. It should be done without a calculator.
Call me at 19 minutes, you think we can get it done?
Oh, we're just doing 1 through 16.
Come on.
I would have to disagree. Nothing on here is difficult.
It's really lazy. So, like,
What are we doing the rest of like different